Hello, 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 everybody, and welcome back. We're looking at question number 19 now on our 2019 Fermat paper. The function f has the properties that f of 1 is 6, and f of 2x plus 1 is 3 times f of x, for every integer x. What is the value of f of 63? Well, okay, how do you handle a question like this? We only know so much about f. It's not like we're given a formula, and it's not particularly likely that we might come up with a formula, although you're more than welcome to try. But this property might only hold for integers, in which case it's going to be very hard. But we do have some ingredients. We do know at least a value of f, and we know how to we know a way to take a f of a bigger number and express it in terms of f of a smaller number. 2x plus 1 is bigger than x. So here's what we can do. I want f of 63. Can I write 63 as 2 times something plus 1? Well, certainly we can. It's 2 times 31 plus 1. So what does the rule tell us? Well, 2 times x plus 1 changes to 3 times f of x. Do we know f of 31? No, but we can write 31 as 2 times 15 plus 1. And in this way, we can slowly work our way down, and we should be able to work our way down to 1. F of 15 is 2 times 7 plus 1. And so that gets traded for another factor of 3. And then we get to f of 7. And 7 can be written, I'll just write it off to the side so I don't run out of space. 7 is 2 times 3 plus 1. So I can change f of 7 for 3 times f of 3. And 3 can be written as 2 times 1 plus 1. So I can trade f of 3 for 3 times f of 1. But we know f of 1. It's 6. That's the only one they actually tell us. So we get 3 times 3 times 3 times 3 times 3. That's 243. And then we multiply that by 6, which you might be able to do. It's just going to be 2 times 729. So that should be 1458. Of course, if you need to, grab a calculator. No shame in that. Okay, so 1458 is right there. It's an answer of D. Now, if you're curious about this, I don't know how it is for other values, but I noticed 63, 31, 15, these are all powers of 2 minus 1. So it looks like you could probably prove sort of this general rule that 2 to the n minus 1 is going to be 3 to the n minus 1, actually 3 to the n times 2. That's certainly what we've got here. This is 3 to the 6 times 2, and this is 2 to the 6 minus 1. That's kind of cool. We don't need to know that to answer the question, but nice little after-the-fact knowledge. Okay, so that's question number 19. Up next, of course, we're going to finish off part B with question 20.